In this video, our goal is to solve sine squared theta plus 8 sine theta plus 7 equals 0, rounding our angles to 2 decimal places. Because we have a sine theta squared in this equation, the equation is quadratic. To make it easier to solve, it'll be helpful to make a substitution. Let's let x be equal to sine of theta. Substituting x for each of the sine thetas gives us x squared plus 8x plus 7 is equal to 0. So now we just have a quadratic equation. We have different choices for how to solve it. One way that always works is the quadratic formula, but in this case it appears that we'll be able to factor because we can find factors of 7 that add up to 8. 7 factors into 1 times 7, and 1 plus 7 is equal to 8. So we can factor this into x plus 1 times x plus 7 is equal to 0. Now we set each factor equal to 0. We get x plus 1 is equal to 0, or x plus 7 is equal to 0, which means that x is equal to negative 1, or x is equal to negative 7. At this point, we can substitute sine theta back in, and we have sine of theta is equal to negative 1, or sine of theta is equal to negative 7. Now for sine of theta equals negative 1, we want to recall our unit circle. And we want a y-coordinate of negative 1, which would be at the bottom of the circle. And that corresponds with 270 degrees. So theta is equal to 270 degrees. Sine of theta equals negative 7 would mean that we'd have to find a point on the unit circle with a y-coordinate of negative 7, but that's impossible. So there is no solution to sine of theta equals negative 7. So it appears that we have just one solution. Theta is equal to 270 degrees. But just to check and see that our answer seems reasonable, let's solve the equation graphically as well. Go to Desmos. We'll enter y is equal to sine squared x plus 8 sine x plus 7. And our other equation will be y is equal to 0. We'll go to settings. Make sure that our calculator is in degree mode. We want solutions between 0 and 360 degrees. For our y-axis, we try negative 10 to 10. Actually, just looking at the graph, maybe we need to make our y value bigger. Let's try 50. That looks a little bit too big. I'll do 20 instead. From the graphs, we see that there is indeed just one point of intersection between 0 degrees and 360 degrees, and that's 270 degrees. Now, one thing I'm curious about is, are there any other solutions further out? Let me go ahead and adjust the settings. And I'll go from, let's say, negative 360 to, double 360, that would be 720. And notice that there are other solutions. We've got one at negative 90, 270, and 630. And all of these are 360 degrees apart. All of those angles are coterminal with 270 degrees. So coming back to our equation, it didn't really specify that we had to find angles between 0 degrees and 360 degrees. It just said solve the equation. We want all the solutions. So the solution is that theta is equal to 270 degrees, or any angle coterminal with 270 degrees. And a way that we can write that down symbolically is that theta is equal to 270 degrees plus 360 degrees times k where k is an integer. So for example, if k is equal to -1, then we get theta is equal to 270 degrees minus 360 degrees. And that's the -90 degrees that we saw on our graph. Or if k was equal to +1, then we would have theta is equal to 270 degrees plus 360 degrees. That corresponds with the 630 degrees that we saw on the graph. And if k equals 0, then we would just get theta is equal to 270 degrees.